And this is our first lesson on natural science and technology, okay? So it's good to have you here. It's good to have you here. I see Nogwanda, I see Kayla, I see Unati, see, is it Noah? It's good to have you here, guys. Let's continue with our lesson. You are very welcome, okay? Zoe, hi to you too, okay? So today's topic is materials around us, okay? So as you know, we are not the only physical beings on earth, okay? And more than that, we as human beings interact with a lot of things around us on a daily basis. So I want you now to look around you and tell me what materials can you see right there at home. Just type here in the chat box and tell me what materials do you see there at home. Okay, is it Nolis? Let me see here. Nolis says that he sees a heater or she sees a heater. Let me just see. What's your name, Nolis? Nati. Okay, Nati says that he sees a heater. Can you hear me now? Bello? Good. Okay, Nwanda says that he or she sees a book. Okay, Mornay, a plastic bottle, TV, fridge. Okay, so one thing I want you to realize, okay, Oravile says wood. I like your answer, Oravile. Nati says a washing basket, a printer. Good. Now I want you to realize something, that each of these things that you mentioned here, like heater, books, a plastic chair, plastic bottle, a TV, fridge, laptop, basket, washing machine, printer. Each of those things are made of a certain material, okay? And that material can either be a solid or a liquid, okay? A solid or a liquid. But more than anything, I want you to look at the different materials and I want you to tell me what they're made of. Are they made of, I see here there's plastic. I see materials made of plastic, like a plastic bottle, for example. And I see here wood. And what else? For example, what is the heater made of? What is the printer made of? Laptop also. Oh, okay, Zoe Rose. Okay, Zoe Rose is using, okay, no worries. Thank you for that. A wooden chair, Warabile says that this is a wooden chair, so it's made of wood. So that should tell us that the materials, okay, Kira, good to see you here. So I want you to focus a wooden table, yes, 100%. So we see that the materials or the ornaments that are around us are made of certain materials. And I see here most have mentioned wood. Okay, don't switch on your cameras, okay? Please don't switch on your cameras. Hi, Ompile. Good for you to join us here. Okay, right, at the end of this lesson, you should be able to list different types of materials that are found at home, and you should also be able to display an understanding of the change of state of materials that you see at home. Okay, right. Okay, so someone identified a whole lot of wood and some plastic. I didn't hear stone because some tiles are made of stone. I didn't see any metal. Hard to find. I didn't see any glass. No one said glass. No one said some. I want you to look closely because that's what I see. Steel. Good, Tebelo. Tebelo sees some nice shiny steel. Noah says paper, wood, cardboard, plastic, and tile, 100%. Thank you. I see wood, really. Right, from the picture alone, what materials can you see? That's from the picture on the board. A whole lot of wood. There's a whole lot of, there's some stone, yes, on the walls right here, correct. There are wooden cupboards, okay. What else? There's metal, yes. I see some metal there. Bricks, yes, true. Sink, okay. There's a sink here, okay. What else? A metal oven, okay. What are these guys? These right here. What are these made of? No one is saying anything about these. These right here. Slides. Thank you. Yes. Okay, so those are the obvious and notable materials that we can see around us. Yes, 100%. Okay. So there are different substances, okay, around us that we use each and every day. And a few of them are, for example, water and tea, cooking oil, for example, cooking gas, and air. Air is also a substance, and also petrol. Good, they're also fabric chairs, okay. So these substances can either be physical or solid, okay? But they can also be liquid, okay? So tell me, things like butter or wax, are they solid or are they liquid? Solid, 100%. Butter and wax can be solid. And what happens if you heat them? What happens if you heat butter and wax? Don't just type liquid. Say they turn to a liquid form. Turns to liquid, 100%. Tebello, thank you. Okay, so let's talk about the changes in state. Okay, why do substances change in their state? Okay, so the primary catalyst and reason why substances change in state is because of heat. If you add heat to a substance, that causes change. That causes the material to change its state. For example, when you heat water, if you give it enough heat, it changes to a state of steam. And obviously, when you cool it down, then it changes to a state of ice, okay? So this usually means that the changes in state can be reversed, and it usually depends on the heat or temperature that you expose it to, okay? Have it together. Junior, I don't know what you are talking about, but I don't want you to, okay? I don't want you to disrupt the class, okay? Okay, all right. Okay, so, materials generally are made of metal, okay? And this is the reason why actually materials change. Or let me rather ask you a question. Let me rather ask you a question, okay? Why do you think that materials change in form? Why do you think materials change their form? What happens to them? Why are they solid? Why do they change to a liquid form? And why do they change to a gaseous form? Especially when you expose them to heat. I'm waiting for your answer. Okay, I see. I think it's Simpiwe. Okay, let me repeat the question. For example, why does ice remain solid, and why does it lose its solidity and become a liquid when it is exposed to heat? And why do liquids change their form from liquid and become gases? If you know the answer, I want you, listen carefully, don't post it on the chat box. I want you to raise up your hand and I want you to tell it to us, okay? Okay, we have hands raised up. Wonderful. Okay, let me see. The hands up. And we have Gabriel, okay? Gabriel? Gabriel, can you give us your answer? Zoe? Zoe?
Hello, Sam.
Hi, Zoe.
How are you, Sam?
Good, how are you?
I'm good, thank you.
You have an answer for us?
Yes,
Okay.
I think it's because different solids, when you have different solids, the molecules act differently.
Okay, true, that's true, yeah. So why do they change? What happens to the molecules when they are exposed to heat? Zoe,
Yes,
what happens to them when they get heated up or when they cool down?
they change their state.
Change their state. That's true, my dear. Okay, thank you.
You're welcome, Sam.
Okay, Does anyone have an answer? Does anyone want to participate? Hey, Tibelo, I'm going to give you a chance to type, okay? Because you don't have a mic, it's okay for you to type, okay? So I'm going to give you an opportunity to type. You can send it to me in private, and then I will read out to the class, okay? Okay, let's hear Unati. Unati, do you have an answer for us? Ella?
Hello, sir. I think it's the change of matter.
The changes in the matter, right?
Yes.
What happens when it's cold? How does the matter behave?
Night snow.
Like snow.
I meant freeze, not snow.
Okay. All right, thank you.
You're welcome.
You. Okay. What we have that for example, what do we as people, okay? What do we do when we feel cold? Do we spread our hands? Do we spread our hands? Do we walk around? Do we go all over the place? Or do we stay indoors and are we closed up? And do we just want to sit in a solid position? What do we do as people? Do we walk around everywhere? Do we run around? We quarantine, right? We stay indoors and we don't want to go anywhere. We want to sit still and we don't want to move. We stay at home, yes. And what do you hug your mommy or your daddy? Do you sit with them in the blankets, or your brother or your sister? Or yes, you stay still under your blanket, correct? So what happens when you feel heat or when you feel hot? Do you just stay? Or do you run? Do you move? Do you want to go everywhere? What happens when you feel heat, a whole lot of heat? You will play, and you don't want to wear a lot of clothes, and you don't want to be next to people. You want to push them away. You feel like they're sitting or standing too close to you, and you move around. Correct, Kingsley, 100%. And that is the same thing. That is the same thing that happens with molecules. Okay, so the molecules, the matter in the molecules, when it cools down, they hug, they stick together. They want to be together because they are more stable that way. But as soon as they're heated, then they start moving around. And that's why they have a liquid form. So the more they're heated, it is the more and faster that they move around. And that is why actually they become a gaseous form, okay? That's why they become gases. So it is all determined by how much the molecules move. When they're heated, they begin to move, and the more you heat them, the faster they move, okay? Are we together? And okay, giving you a warning, okay? Allowed to do that. Okay, so that's what happens, okay? When materials are heated, okay? And because matter is affected by energy, you know, when it absorbs that energy, and energy such as heat, because heat is also an energy, the atoms and the molecules begin to move around. And the more they move around, it is when now the changes begin, the change in the state. Um, so when you see a liquid, water, for example, spreading out, it is the molecules moving further and further apart, okay? Any liquid does that, but it's simply because of the molecules that are highly active or moving more and more because of the energized atoms and molecules inside, okay? So as in the case of steam, okay? Okay. All right, don't worry, okay? All right, so as we saw from today's lessons, is that there are many types of materials and substances that you come across each day. Those different substances have the capacity and the ability to be in a solid, in a solid state, in a liquid state, and also in a gaseous state or a steam state, okay? Yeah, I see there are people who have their hands raised up. You can just send me a message. Send me a message. I'll be waiting to answer your question, okay? Okay. So I want you to tell me on the chat box, tell me what have you learned from today's lesson? What have you gathered from today's lesson? What have you learned from today's lesson, class? Okay, Develo says we learned about materials. Okay, Unati says about the change of state. How many states do we have? How many states did we talk about today? Solid and liquid. What is the other states? No, 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 no. It's not two. We spoke about three. What is the other one? Gas, 100%. Thank you. It's gas, liquid, and solid. Wonderful. Okay, and what causes the change in the state? What causes the change? What makes the change to happen? Heat, 100%. And how does heat change the state? what happens to the matter or the atoms and molecules in the matter? What happens to the, okay, I see here Zoe says that they go apart, they start to move, okay. All right, thank you, Arifa. Okay, it turns to steam or smoke. Okay, thank you. All right. Why do they move though? Why do they move? Yes, Kira. Heat makes them move, but why? Okay, Malik says it's because of how hot it is. Okay. Remember, I did say that they move because they absorb energy, okay? And the more energy they have, it is the more they move around. And it is similar to us as people. When we have a lot of energy, we begin to move around. But when we have less energy, we don't move a lot, okay? All right, let me give you a class activity. And then, okay. Questions on the chat box. Zoe, do you have a question? Zoe?
No, sir, I don't have a question.
Okay. Right. Let me give you a class activity, okay? So I want you to write down different properties of solids, liquids, and gases, okay? For example, solids are hard, so they have a certain shape, and that shape does not change, okay? It is a definite shape. That is an example of a property of a solid, okay? Another property of a solid could be their mass. Because solids are stable, they don't lose any of their mass. So that is one property, is that they have a definite mass, okay? The mass doesn't change. Okay. Unati, I want you to do this now. Twelo, I want you to do this now. I'm giving you around, let's say 10 minutes. No, 5 minutes. Let's make it 5 minutes. And I want us to discuss. So when you're done, just raise up your hand and we'll discuss the properties of solids, liquids, and gases, okay? Hello? Okay. Thank you, Simpiwe. I didn't see your answer, okay? Simpiwe said that molecules move, change state because of the heat and of the energy in them, 100%. I didn't see that. Thank you, Simpiwe. Hey, Jordan. See. Amari Noah. All right. Amari says that different types of materials, some stay solids when they react to heat, and some don't. Some don't. Some solids tend to different sizes because of both the molecular move apart. So, so liquid and then just steam. Yes, no, that's correct. Sorry, I missed that. Although I did say that you must raise up your hand to read your answer. Okay. Right. So this is the question I'm giving you for the classwork. I want you, when you're done, I want you an answer. I want one person to give us one property of mass, one property of a gas, and one property of a liquid, and how they compare with one another, okay? So remember, when you talk about comparing, to compare is to look at both the differences and the similarities, okay? So the word compare doesn't only focus on the differences, but also the similarities. So look at both the differences and the similarities, and that's how you compare it to see how they compare with one another, okay? So it's when you say compare, you're not actually saying differentiate, but you're saying compare, which refers to both differences and similarities, okay? So, okay, I want this conversation on the chat box to stop, okay? You have 2 minutes left, and I see hands already raised up. So let's have Zoe Rose. Zoe? Zoe? Zoe is leaving. When you're done, can you just raise up your hand so that we can... No, we are not done. Where are you going? Okay, let's have, is it Tareen?
Taryn.
Taryn, okay. Taryn, give us your answer, please.
It's not an answer, it's a question.
I'm listening.
Are we solids because we change our weight? Do you say You said that solids, they don't change their weight.
Oh, you mean people?
Yes.
Oh, okay. People are both solid and liquid and have gases in them. Okay, so we do not classify people under any, because your bones are solid, but your blood is liquid and you have gases inside. Okay.
Like digesting gases.
Yes, like digestive gases. Okay. So
we're all
the reason why you change in your mass is because your body,
by growth.
huh?
By growth.
You grow, yes, and that is when actually you increase in mass, and you decrease also in mass because of the calorie intake. For example, the amount of food that you eat also affects how much weight you have. So you could either eat more and grow in your mass, or you could eat less and also grow in your lose mass.
Okay.
Yeah.
But what is our skin a liquid, solid? I'm wondering if our skin is a solid or a liquid.
It's a solid, my dear.
Okay.
Yeah. Do we have Zoe Rose, also known as Mornay's iPad? Hey. Mornay? Can we have Mornay, please? Okay, Arifa.
Hi, how are you?
How are you, Arifa?
I'm good, thank you.
Yeah.
So you're going to compare solids, liquids, and gases. I would say a solid has a definite shape, while a liquid is more flexible. It can move. It doesn't have a definite shape. And
Wow.
gases all everything around you, so it's more flexible. It's able to move.
Wow. Good, Arifa. Okay, thank you for your answer, Arifa.
You're welcome.
Do we have let's have Gabriel. Gabriel? I have Noah. Grade 4.
Hi,
That's a word
sir.
of advice. Huh?
Can you please repeat the question?
It's on the board. It says write down and compare the properties of solids, liquids, and gases.
Okay, thank you. Amali, you can say your answer.
If you can, I'll give you a chance to actually post it on the chat box. Zoe? Thank you, Zoe.
Sir, so
Huh?
a solid is hard and the molecules are stuck together
Yeah.
so that it takes a shape, and a solid doesn't take the shape of the container it's in.
Wow.
And liquid, the molecules are far apart,
Yes.
and it also takes the shape of any container that it's in.
Thank you. 100%. I like that.
And a gas is air or cooking gas or other types of gases, and
Yeah.
and air is all around you.
Okay. Wow. Thank you for that. Okay. I'm giving you an applause. Okay.
Welcome, sir.
Hey, let's have Unati. Unati. Kingsley, what are you using? Are you using a phone? Just send me a private message, Kingsley. Hear you. I think there's something wrong with Unati. Unati's microphone, because I can't hear Unati Kaba. But he's already unmuted, so it's fine. I think his name has a capital U. The other one, Unati. The other one. Hey guys, fine. We'll continue on our next lesson, okay? It seems like there's something wrong with your mic. And I'm sorry for those that I couldn't give an opportunity to talk. I have the last person, Jordan. Do you want to say something?
No, sir.
Okay. Right, guys, we have come to the end of our lesson today, okay? So thank you for being such wonderful students. Thank you for all your participation. Thank you for the answers that you gave. I see and I saw some brilliant answers. I see some brilliant students here, and I hope to see you again tomorrow, okay? Thanks, everyone. Bye.